Jamaica and Colombia. Coulombs. Eh? Coulombs. Hey. No waste time. I'm Hamish, but a lot of people like to call me. Let's get started. So we don't want to waste time. Let's get to the business. So first and foremost, let's say here the figure shows the equilateral triangle ABC. ABC is all the distances are equal. Half A together means this is A. So A, because this is half A. Anyway, this charge is same with this charge, same with this charge. A positive point charge Q means this is charge Q is located at each of the three vertices. Means here means positive. A point charge Q, so we decided to place point charge Q here. Okay, that can either be positive or could be negative. So we don't know for now. Okay, so later we're gonna find out. It's placed at the midpoint between, just like how we see here, B and C. We place this charge, but we don't know whether it's gonna be positive or negative. Now they want us to determine the expression for the magnitude. For the magnitude and sign of Q. So we need to get the sign of Q and magnitude so that the net force on the charger A is 0. Oh, okay. So we want to get a net force on charger A has to be 0. Now let's see how we can calculate. Before we get started, let me show you some few things. Some people don't know. Okay. If I have, let's say this is charger A, let's say this quantity of charger A and this quantity of charger B. Okay, so either one can be positive or negative. If both charges are negative, let's say negative and negative, it's charger. So let's say we have a distance 2 meters. So if both charges have got the like signs, means we're gonna have a force of repulsion, you know. But okay, let's say plus and plus also, we're gonna have a repulsion. Repulsion means they're gonna repel to each other. So either negative and negative or positive and positive, they're gonna give you what? Repulsion. They're gonna repel to each other. But when the signs are different, if this is plus and this is minus, or minus and plus, means so those charges, they're gonna attract to one another. It's gonna be force of attraction. Just like a male and female. It's easy for them to get married, you know what I'm saying? But a female, you know, so stuff like that, you know. So now, so we have a formula. We say force of attraction or repulsion of, let's say, A to B of the two charges A, B. Let's say you always take what? K constant, which always given, times charger, let's say charger A for this case, which will be charger 1 times charger B times this charger here over the square of the distance between. So you take the distance between the square. For this case it's 2, it's going to be 2 square. That's how you get either force of attraction or repulsion. You know what I'm saying? So this is a formula I use. Or if this is Q1 and let's say this is 2, so you're going to say Q1 times Q2. But if this, let's say, is Q and this is just a Q also, so we're going to say this equal to K, Q times Q over square of the distance between. Let's say square, we don't know, so we say R. Let's say this is R. It depends how they're going to give you. So when you say, okay, force of repulsion or attraction, because it depends if the sign are the same or the sign are different. You know what I'm saying? So for that case now let's come to the business. Okay, so apart from that, let me show you another thing also very, very important. So that when I start to solve this question, it's going to be easier for you to understand. Okay. If you have a triangle like this, okay, so this is hypotenuse, this adjacent, this hypotenuse, and this adjacent, and let's say this is angle theta, we know this is opposite. So opposite is like vertical. So anything vertical is like, you know, y-axis. Look, anything vertical is always y-axis, and anything horizontal is on x-axis. You know what I'm saying? So for that case now, simple method. If somebody gives you this, okay, let's say this is 30, they should give you here 4. They say find adjacent and find the vertical. So if you want to get this, you know, I have a reason why I'm doing this. So when I come here, it's going to be easier for you to understand. You know what I'm saying? If somebody say find the adjacent, remember adjacent is cos. Okay? So I want to say if I want to get this horizontal, which is adjacent, I'm going to take my hypotenuse times, take this multiplied by the cos, because it's adjacent, horizontal, for whatever is here, hypotenuse times cos of your angle. But for opposite, Opposite always, remember, is sine. So adjacent is cos always. Just put it in your mind. And for vertical is sine. So I'm going to say sine of my angle, for this case is 30, for this case times my hypotenuse always. Simple like that. You know what I'm saying? So remember that, because that's what we're going to be doing right now. Okay, so how if somebody give you this? Okay, somebody give you, let's say, some stuff like, let's say, excuse me. Okay, so which one is adjacent here? Hypotenuse. So we know this is hypotenuse. So they kind of change the triangle. So for you to know whether hypotenuse, adjacent, make sure you look at your angle. If this is my angle, angle is always between hypotenuse and adjacent. So you have to look at your angle. You know what I'm saying? So this is my angle. Oh, so if this is my angle, is between always hypotenuse and adjacent. And then this is going to be opposite. So for that case, now they say, find this. Okay, let's say this is A and this is alpha. So I'm going to say, oh, my adjacent for this case is like a cos. You see, they kind of turn this triangle. So I'm going to say my adjacent. Okay, adjacent always cos. So I'm going to say cos. Where's my angle? My angle is alpha times hypotenuse. Oh, so this is for this case adjacent. Now we go up. What about this one? This is opposite. So opposite, take hypotenuse times by sine of alpha. Now one more, the last one. And then we know when you come in, we're going to be running now. Okay, so somebody give you this now. Okay, let's say this is 4. Okay, find this and this. Okay, so which one is adjacent here? So I'm going to have to look at my angle. Okay, this is my angle here. So my angle always between hypotenuse, because we know this is hypotenuse. Angle always between hypotenuse and adjacent. Whenever you have an angle in this stuff on triangle. So this is hypotenuse and this is in adjacent. Oh, so adjacent always cos. So I'm going to say adjacent equal to cos of my angle, which is 60, times hypotenuse. Now come here. This is opposite. You know what I'm saying? Because if this is adjacent, that's opposite. So it's okay. So this could be opposite. We know is sine. So say sine of my angle times hypotenuse. So now let's come here now. So we're going to be doing this tricky right now from now on. So first and foremost, I'm going to do free body diagram. So let me raise and make a space. Let's draw free body diagram and solve this question quick. Now you understand all the important concepts. Okay. Okay. Okay, so free body diagram, free body diagram. Okay, now look. If I have to resolve this triangle, look, I'm going to say, let me do this. Because you know what? Look, I have a charger between means I can find the force of attraction or repulsion, because for now we don't know this charger. So we don't know whether it's going to be repulsion or attraction. If it's going to be, because we know this positive, they have taught us there, positive, positive, positive. But this we don't know. It depends. It could be positive, negative. If it's going to be negative, they're going to repel with this because it's positive, negative. If this and this is going to be repulsion, repulsion. But this, we don't know. It's all depends on this. But we want to get the net force at here. Force net at A, it must be equal to 0, neutral. Now, how are we going to do that? So first and foremost, let me find the distance from this this A to Q. Okay, how am I going to get distance? Look, this I can do Pythagoras because I have a hypotenuse, I have adjacent, and then another thing also, look, this is 90 degree. And this one, this is, if it's 90, remember, if this is equilateral triangle, I mean this is going to be 60, this is going to be 60, all of it, and this is going to be what's going to be 60. So 60 means this must be 30, and this must be 30, and this is going to be 60. 60, 60. Okay, so now let me focus on one triangle now. Excuse me. I have A over 2, I have A. So I can either can use Pythagoras. Okay, let me show you two methods. If I use Pythagoras, I'm gonna say, oh, I wanna get this length here. Let me say length equal, how I'm gonna get length means length square equal to this hypotenuse square minus A over 2 also square. And this is gonna give us A square minus this gonna be A square over 4. And this is gonna give us 1 minus 1 over 4, 3 over 4 a square. So length square equal to 3 over 4 a square. So we're going to square root and we're going to square root. So our length here equal to 3 square root over 2, because you can square root the denominator, you get 2. And when you square root a square, you're going to get a. Oh, so this is the length, because here, let me separate slowly. Square root of 3 over 4 times square root of a square. So this is going to give you square root of 3. When you square root 4, you're going to get 2a. Okay? So this is the length here. Or if you don't want to use that method, you can just use SOHCAHTOA, I mean normal trigonometric trick, which saying, okay, let's say I have this is the triangle. Okay, this is 60. Okay, this is a. Okay, now we're looking for the length. So now remember, this is hypotenuse, this is adjacent. We want to look for opposite, which is this length. Opposite sine. So we're going to say, oh, so I'm going to say sine of which angle? 60 times hypotenuse, which is a. Okay, what is sine of 60? Sine of 60 equal to sine of 60, I think it's square root of 3 over 2. Sine of 60, yeah, of course, sine of 60. Yeah, square root of, which is more easy. So a square root of 3 over 2 is like our square root of 3 over 2a. Oh, so this is going to be this length. You see, that more easy compared to Pythagoras actually. Okay, so we have a length here, which is square root of 3 over 2. We have a length already. From here to here. Why do we find length? Because we want to get the force of either repulsion or traction, since we don't know this one here. So now, let's draw a first free body diagram, since we have everything. Okay, so I'm going to erase this stuff and draw the free body diagram. Okay, free body diagram. Excuse me. Okay, now let's go free body diagram. So how are we going to do the free body diagram? Look, so first and foremost, I want to get from each one. Okay, so I can get the force from here to here first, and I can get the force from here to here first. Okay, so now free body diagram. Okay, I'm going to say, okay, look, I'm going to say, okay, look, I'm going to say, okay, so first and foremost, I can get this force of AB. Let me get force everywhere. Okay, let me share the color here quick. So force of AB here, we know it's going to be the partial, of course, because same force equal to K. K is constant times face of this charger times this charger over square of the distance between. What is called distance between? It's going to be A square. But even here also it's going to be the same, because it's going to be force of AC equal to this charge on is Q, K times Q times this Q over square of the distance between. So same as say K Q square over A square, which is going to be same with this, equal to K Q square over R A square. My apologies, not R square, it's A square. This is square, A square, A square. Okay, so now we want to get the force of A, the repulsion or traction from A to Q. So we're going to say, oh, okay, so force, before you draw free body diagram, so we say force of AQ, which is going to be downwards, but for here we don't know which direction is going to be acting. So even this for now we don't know. Say, because I'm going to be, okay, let's assume we don't know, and then I'll show you how to draw free body diagram and figure out how you're going to make it zero. Okay, force of AQ is going to be equal to K. Okay, which charger here? We know this charger is Q because it's Q, but which charger here is bigger Q over the distance in between them is, oh my god, this is A, sorry. It's good, A. Okay. Remember, we say here, we got it. Oh, you want me to do it again? I think you might have noticed my mistake, you know what I'm saying? Okay, look. Just in case. This was 60, and this was A, and then we say we want to get opposite. Opposite means sine. So we say, oh, so opposite, hypotenuse times sine of 60. So it was A square root of 3 over 2. Okay, cool. So distance is going to be what? Square of the distance means square root of 3 over 2a, all of it you must square. And this is going to give us k, q, bigger q, and this is going to be, when you square this is going to give you 3a squared is a square. Square root of 2 is going to give you what? 4. So we can take 4 to the numerator. Okay, this is going to come to the top. This is going to be, okay, this is equal to, okay, let me write here. Force of AQ equal to 4 KQQ over 3A squared. Oh, so I have all the force I need. Okay, now let me show you how to draw free body diagram now, and then we can finish up this question. So we're going to say now, for free body diagram. So now you think in common sense. How are you going to make this stuff zero? How is it going to become zero? If you have a 3 force holding in 1.3 force, how is it going to act for you to get 0 Newton? Oh, look, if you here, let's say this is the force. We want to make this to be 0. You know when I say 0? Means net force equal to 0. Means this stuff is not moving. Like, there's 3 force pulling here, A. But those 3 forces, when they pull, it has to be a point where this stuff, okay, for example, okay, if you pull here, this is Hamish, this is you, and this is Salman, let's say your friend. If we're going to be pulling each one, let's say here I've got 30 Newton, you have a 20 Newton, I have a 40 Newton. Where this is going to be moving? This stuff is going to be like kind of, because not the same force. You know what I'm saying? So if we're going to make them all them equal, let's say this is 30 also and this is 10. Mean it's not going to move because the same force is going to be the same. Mean there's no net force. You know what I'm saying? So now, for us, if we have a 1 force, 2 force, 3 force, for this to be at equilibrium or no net force, but anyway, we have to write the free body diagram in a point where like, okay, let me show you now how it's going to look, because if I'm going to say law, it's not going to make sense. So this is going to be like this, my opinion. So this is going to be, let me from here, okay, so this is going to be like this. Now, see this force here? This is going to be like, okay, this force, okay, this moving down, right? Okay, let's make this one moving down. So this force we have, so force of AQ, what is FAQ? Equal to KQ, K, small q, bigger Q over, this one, excuse me, 4, we have a 4 here, and here we have a 3A squared. 3A squared. So this is the force which is moving down. Okay, if this, let's say, move down, let's assume it move down. What happens with these two forces to make it equilibrium? Means, but anyway, if this move like this, is not going to be at equilibrium. But anyway, this must move like that, and this must move like that to make equilibrium. Means this one, its direction must be that way. Means the direction must be this way. Like this, if act that way, and this must act that way to make it 0. Does that make sense? Means so that it can be stable. Means no net force. It does not move at equilibrium. You know what I'm saying? So this is A. Remember, this is Q. No, this one is Q. Q. And we have this distance, which is L equal to square root of 3 over 2 A. Okay. This one we have a force, that force, because this is, like I say, this is we have this force which is K force AC. K force AC equal to K Q square over A square. Okay, what about that one? Same thing, KQAB means AB, C means it must move that way so that you can keep this equilibrium. Force AB equal to, same thing like this, KQ square over A square. Now, let me say something here very, very important. Okay, let me do this. Excuse me. If this is 60 for maternity, if this is 60, this must be 60 also. Because look, excuse me. Vertical opposite means this and this must be the same, this and this must be the same. Means look, this angle, because look, we take that way, mean these angles will be equal to this one. So this is 60. So in other way you can do this. This is 30 and this is 10. You know what I'm saying? So our intention now, let me show you now. So how we're not gonna use this stuff. You know, we can use, but let me show you how to resolve. So this is a free body diagram. This is free body diagram. Free body diagram. Free body diagram. Now let me show you now how you can do. So what you can do now, get that, because this force acting vertical down. Let's make this force is that is vertical upward, vertical upward. Because you know it go that way, it go that way. So we can make, okay. Let's resolve a small triangle. So this is a free body diagram. You have to draw like this in exam. But what I'm showing you is how to resolve. So I'm going to say, okay, if this force move that way, okay, so if this force move that way, if I want to make it like this, look, I want to do this. And let's join triangle. So we know this is 30. Okay. If this force move that way, how are we gonna make connected triangle? Means this must move that way. This is a component of it, of this actual force. Does that make sense? Because this one move that way. So if you want to make horizontal, means like this. This one move that way. You want to make vertical, must move like that. Okay. So we have a triangle here. You know what I'm saying? We have a triangle here. So look, let me draw here aside so you can make a lot of sense like this. Now you have like this is 30, and this is FAB, and this is okay. So now, okay, now let's go this hypotenuse, and we want to get what? The hypotenuse. Angle is always between hypotenuse and adjacent. Memorize that. Whenever you have a triangle, however they're going to turn it, your angle always between hypotenuse and adjacent. So this adjacent, and adjacent we know is cos. So this is going to be cos. Cos of which angle? 30 multiplied by the hypotenuse. Okay? If I have this, right, I want to get this force. Okay? I want to get that force because we have a free body diagram. Okay? So now we say total upward force equal to total downward force. So it's a summation of total downward force. Total downward force equal to total upward force. You know, so total upward force, or sum or total upward force, equal to total downward force. Downward forces. Okay, so what is a downward force? Downward force, we know this one, which goes down. But we don't have this, we only have that force in that direction. So how are we going to get it? Look, if I have this triangle here, look, small triangle. This triangle go that way. So if you want to get this, how are we going to get, look, the angle is 30. And then if this one, if I want to make vertical, it's going to be like this. Excuse me, like this, and it's going to be like this. Because look at your arrow. So this component of force, dot, is going to be facing up. And look, this is your original actual force. So if you want to make horizontal, look, it's going to be like this. It's going to be facing this way. Oh, so my intention, I want to get the vertical one. If this is 30, and this is my hypotenuse, if force AB equal to K Q square over A square, which you got it already. So now look, use your common sense. My angle is always between hypotenuse and adjacent. So always, it doesn't matter how they turn your triangle, look at where's my angle. So my angle is between hypotenuse and adjacent. This is my hypotenuse, what adjacent? For this case. Oh, okay. So now this adjacent. Adjacent meaning what? Cos. So it's going to be, oh. So take whatever hypotenuse you have times cos of 30. You know what I'm saying? Times cos of 30. Okay. So this is Fy because it's going up. Okay, so Fy. Or you can say Faby. You know what I'm saying? So we have a vertical red because we want to get what? Total upward force. So we have total upward force here. Even here it's going to be the same because even the components are the same. Look. So it's like now, it's like this. This is the force I have. And also here is 30. So if this move that way means this is going to be moving upward. This move that way. So if you want to put horizontal, it's moving this way. But what do I need? I need upward force. If this equal to FAC, A and C from that triangle, because this was A and this is C. So I'm going to say, how am I say? Remember these charges Q. Okay, charge a Q, and this is bigger Q, which we extract from the triangle. You know what I'm saying? So we're going to say, to get this vertical component, you're going to say, okay, so now this equal, because I want to get sum of here, and this must come here together, equal to the one which is moving down. So this equal to, this is adjacent. Why? Because hypotenuse, and there's an angle, hypotenuse always with, it make angle with adjacent. So we're going to say, this, let me say, cos. Why I say cos? Because this is adjacent. Cos of 30 multiplied by this hypotenuse, which is K Q square over A square. Oh, okay. I got it. So now we have both this force here, which is this, And this force, which is this, which are the same, just like this plus this, are upward force. So total upward force is going to be this plus that. You know what I'm saying? There we go. So we're going to say, okay, so now let's take this plus that. So we're going to say, okay, so we add them, it's like the same thing, but so we're going to say two of them, 2k q square over a square cos of 30. This is a total upward force because when you add a plus a equal to a, look, same two of them equal to, so I'm going to write here, total downward force, we got it, which is this, moving down. Okay, what's down first? This one, which is 4 what? K, small q, bigger q, over 3a squared. So we can cancel some of the stuff. And we know cos of 30. What is cos of 30? I think it's square root of 3 over 2 if I'm not mistaken. Cos of 30 is square root of 3 over 2. Oh, sorry, excuse me. So this is going to be 2 times k square over a square root of 3 over 2 equal to 4k q times q bigger 3a squared. So we can cancel some of the stuff. 2 and 2 cancel, k and k cancel, a squared cancel. So we want to get this big q. One q and one small q go. So we're left with one small q square root of 3 equal to 4. This is what we're looking for, over 3. How did I know? The geometric expression for the magnitude and sign of q. These force. Okay, so we can make these the subjects. So the q, so I can write now like 4 over 3 equal to small q times square root of 3. Okay, so square root of 3. So if I want to make q multiply by 3, divide by 4. You know what I'm saying? But remember, since this is moving downward, so it's going to be negative by any means. I mean, total downward first, we know it's negative by any means. You know what I'm saying? But for now, chill. So it's our q, and right here our q equal to, so it's going to 3 is going to come here, square root of 3, and then over 4, because I'm 3 over 4, and then times q. So this is our quantity of charge, but you mentioned coulombs. But is it going to be positive or negative this charge? It must be negative because move what? Move downward. So we're going to say our q equal to negative 3 square root of 3 over 4 Coulomb. Q, Coulomb. And Jamaica and Colombia, Coulombs. Hey, Coulombs. Hey, we're done, man. So if you face so simply say, so if this charger equal to this Coulomb, mean this charger is gonna make this magnitude at A to be 0. I mean the force from here to here is going to be same with the force from here to here. It's going to be the same force from A to Q, and that's going to cause no net force. You know what I'm saying? Means the magnitude of a force in other way at point A. So force at A is going to be equal to 0 Newton when, so force at A is going to be 0 Newton when or if when Q has a charge of negative 3 square root of 3 over 4 q, small q, Coulomb. Sometimes I kind of misspell. Man, if you FaceTime, listen, for all the FaceTime, make sure you come here, okay? If you FaceTime to my channel, come right here and subscribe, okay? Thank you for, hey, we out, I'm out.